Okay, this video is about inverse functions, and it's what we're talking about in 6.12 in Algebra 2, but one of the reasons we have to talk about it in this chapter with exponential functions and log functions is I can graph an exponential function by making a table, making some values, like if it were y equal 2 to the x, I could say 2 to the negative 1 is 1/2. 2 to the 0 is 1, 2 to the first power is 2, 2 squared is 4, and I could graph that. Okay, and it's not so hard to do that, but if I were to have like log 2 of x, how would I graph that? My brain just doesn't even know what to do. We take advantage of the thing called inverse functions in order to graph this. In an inverse function, if I put a number in, let's say I've got some function, and we'll let this box represent the function. If I put, for instance, the number 1 in like I have here, I get 2 out. Well, its inverse function would do the opposite thing. It would have me put 2 in and get 1 back out. So if you think about it, if you wanted to graph an inverse function, all you'd have to do is flip the x's and y's and you'd have it. For instance, if I graphed y equal 2 to the x, I've got these points. If I want to graph log 2x, I could actually make the table for its inverse, y equal 2 to the x, and then I could flip the point so that I could graph log 2x. So I'd say, okay, for this first point, I'm just going to flip the x and the y. I would say at x is a half, y is negative 1. At x is 1, y is 0. At x is 2, y is 1. Do you see how you're putting a number in, get a number out, you take that number, put it in, and you get back to your original number. So all these points can just get flipped, and that's what the whole idea of inverse functions is, and it's what helps us graph log functions. And so we need that in this chapter because if we want to graph a log function, it just would be so hard to do it without this method. So if we're looking here at these points here, for instance, at this first example, if I want the inverse function, all I'll need to do is switch each one of these x and y's. So it would be like negative 1, 1, which would be here. 0, 2 if I flip it, which is hard to read, but you're hopefully following along, is there. 1, 3 would if you flip 3, 1, you get 1, 3. If you flip 4, 1, you get 1, 4. If you flip 5, 2, you get 2, 5. Okay, let's see, where's 2? Oops, I misgraphed. No, I didn't. 1, we had 1, 3. And 1, 4 would have been here. This point right here is wrong. I'm going to mark it out in red. Okay, so 2, 5 would actually be here. Now, this original set of points I had was a function. It only had one x. I mean, all the x's were unique. They were all different. But when I did the inverse over here, I'll circle it in blue, it's not a function anymore because I've got duplicate x's. And remember, that's what messes something up with being a function. So this graph and this is a relation, not a function. So sometimes that happens when we do inverses. We get things that aren't functions, but that's okay. So now, if I want to ever graph any inverse of anything, that's what I can do. I can just switch the points in the table and graph it. So that's what we're going to do with our log functions. Now, there's an algebraic way for most things to find an inverse. For instance, if I have y equal x squared plus 3, and I want to find its inverse, because of this idea of switching the x's and the y's, all I have to do to find it is this. Everywhere I see a y, I put an x. Everywhere I see an x, I put a y. So I get this. I'm going to come over to the side to finish it up. Now, once I switch the x's and the y's, that's the first step, switch x's and y's. I'll write it down. Anywhere you see them in the graph. And then your next step to finish up is just solve for y. Anytime we have a function, we want to solve for y. So we have x equal y squared plus 3. If I want to solve for y, first I'll subtract 3 from both sides. So that leaves me with x minus 3 equal y squared. How do I get y by itself? I could square root both sides. And I get y equal, now remember, when you square root, there's a positive root and a negative root. So I would get the positive and negative of the square root of x minus 3. This one would not be a function because there's going to, if you were to graph this, you'd have two values for each x you plugged in. You'd have two different y's because you'd have a positive of a number and a negative of a number. What we usually do in this case, this would not be a function. So in order to make it a function, we would go ahead and just look at the positive half of it and just say we're going to restrict our values to like the positive values, for instance. So that's the main idea in this section. That's all I'm going to have time to fit on this video. Plus the iPad keeps glitching, so I just want to at least save this much of it since it's the main idea of the lesson. We'll be doing more of this in class.